Okay, so my name is Sebastian. Obviously, I don't work for Elasticsearch, but I have this cool Elasticsearch shirt on. I am gonna not give a really long presentation. I'm gonna leave it open for questions and kind of poking around at the database because I don't know how many people have seen Elasticsearch before, but it's a lot different than maybe other things that you're familiar with. NoSQL is pretty easy. If you know SQL and Cassandra, if you've used any of those, you can kind of get your way around. Or this is it works a little bit differently than kind of tools that you maybe used in the past. So, so the first rule of Elasticsearch, it's a search engine, it's not a database. So just keep that in mind as you go forward. A lot of people have these use cases where they treat it like a database, but it's not really a database. And you probably should not use it as such. And second rule of Elasticsearch, super one. Okay. So a very quick history. Elasticsearch is based on Lucene that was written in 1999. And then in 2001, Lucene joined the Apache Foundation. And then some time passed. And in 2010, Elasticsearch was released. It's based on Lucene by Shay Bannon. And now in April, Elasticsearch version 7 got released. So it just came out and they changed a bunch of stuff. So I'm going to show 7 at the end. And there's a lot of stuff that I don't know what they do. They added a bunch of tools. So I'm not really familiar with all the new high-tech stuff they added. So as a quick overview, it's written in Java. It provides near real-time search. And so for a use case at work, I think our cluster has 100 million records maybe. And you can do some searches come back in seconds, some are sub-millisecond, depending on what type of search you are running against. And there's other people in the industry who ingest terabytes of data. I think Uber's one of them. They do 3 million records a second or something. Some crazy number, right? Their cluster's huge. And the stuff that I do at work is nowhere near that. And they have SQL now. When I wrote this, there is no SQL. They use everything is JSON and everything is REST endpoints. So it's your standard. You can use a browser to hit it, and all of the wrapper tools that they wrote are really just sending a web request to the cluster. So they have this custom query domain-specific language, which is just really these giant JSON blobs that you send that tells the server what you want to get back. And Elasticsearch being based on an Apache project or using code from part of Apache project, it's open source. Some of their enterprise offerings are tools that they built on top, and those are closed and you need a license for those. But for the most part, the cluster and everything, unless you're like a big enterprise shop, you can get away with not paying for anything, which is nice. And so the types of queries that they support, kind of standard stuff that I think maybe most databases do today, Postgres. So they do geo-intersect bounding box kind of queries if you're looking for things in an area or within a poly, if that's your thing. They support this aggregations and counts, so you can get results back, and then you can get these counts attached to the results. So I don't know what a typical query would be like. You'd be like, give me all the people in the class that got an A, and also give me the counts by grade, right? You can bucket like all the people into buckets along with your query. And they do this like term, they call it an enum or a term search, but it's enum. So if you want to search for things that match basically enum strings, right? So you're looking for everybody that's in a certain area, in a certain state, it kind of address searches, things where it's not really a full text query, right? There's some distinct values. And then they have this, their big thing is full text, and it's called ranked and unranked. So what they give you that normal databases don't do, if you did like a SQL-like statement, is they will rank the queries based on how closely it matches the search term. And so you can say, give me the top 50 closest matching queries. And these are a little bit slower because there's this ranking that has to go on, and you can also do unranked queries where you just say, give me 10 results back, not necessarily in any specific order. And so a typical use case that they point out that most people do is that I'm not saying that Five Guys uses Elasticsearch, but I want to find where the nearest Five Guys is to my address, right? So I put in my address, and it's going to return to me the top 13 match. I think it was like top 13 matches when I did the website. So what you would normally see in an Elasticsearch search, they might only keep a subset of the data, which is really kind of what's going to get returned in that search. And so in this case, they've got like the location, the name of the restaurant, the address, the hours, whether it serves milkshakes, and then it's going to have a document. Elasticsearch has IDs just like any other database, and they're probably going to link it to a query, to a record in another database, right? So your use case might be like searching abstracts for papers. So you're just going to keep the abstract, the thing that you want to search. You want to make search really fast. So you're going to keep those type of records in Elasticsearch, and then maybe you're going to point that to a database or another data store that really has all of the information, that once you've kind of gotten results back, you're going to point the user to the full amount of information. And so that's like, I think the original real big use case.
So that database ID, that's just something like Elasticsearch is it helping you with that, or is that just something where you know the database ID from Postgres and
You would know that you're making that relationship. They don't have any way of knowing. They might now, right? I think they have a bunch of hook-ins and apps and stuff that you can do, but we have stuff at work where we have a graph database, and we go look for like abstracts, right? And then we pull that back, and then we send the person the actual like paper, and then they can do whatever they want with that. And so we're just trying to get the things that match the closest to their search, which they're like this other database that we use. It's not going to give us that functionality. So, and so the way that this works, the way their kind of thing, I guess, the way they do full text is they do what's called tokenization. So tokenization is you give some text string, and they have all types of different tokenizers. And usually what they're going to do is they're going to like strip the white space, remove the punctuation, potentially remove stop words, stuff that you aren't going to search on, like the word the, is, at, a. And they're going to divide the words on boundaries. And so they have a lot of other stuff. Some people do natural language processing, and so you can do, they call it n-gram tokenization, where you split a sentence into like 3 or 4 or 5 character chunks, and you can do tokenization. And in Elasticsearch, you can have a document that has multiple fields that are tokenized differently, and you can search across them in different ways. So you can have one record serve 2 different search purposes in some cases, depending on what your use case is. So I'll show some of that later. And so here's an example of the canonical, right? The quick round fox jumped over the lazy log. And I have this other one that I forget what these are called. And another thing that tokenization potentially does that I think they have changed what they used to do is they'll strip out the S's. So instead of storing zebras, they'll store zebra. And instead of storing jumped or vexingly, they'll store like vex and jump, the word jump, and they'll remove the LYs and the EDs so that you just have the singular case, because that's really what you care about matching usually. And so this was like one of the tokenizers, lower cases. They have I think the standard, they call it the standard tokenizer. It leaves the upper cases in place. I guess if people were searching for state names or people's names or street names or something that you would expect to have capitalization, and you want that weighted differently than a lowercase. And let's see. I think I have. So the way they store records, the way that search is fast is they do what's called this inverted index. So they've broken down these tokens, and then they store the word with which documents it exists in, and then the frequency. They store the frequency amounts. So they can do a quick lookup. It's like a dictionary search, basically. And that's how kind of the rankings come into play, that they can return you the thing that has the most frequency or the closest match. And this isn't exactly potentially what it looks like, but this is what it does under the hood. It has these inverted indices. And so their big thing in Elasticsearch is what they call an index, and they say it's like a database, in a relational database. It has a mapping which defines types. It's basically a table. They use the term index, but it's basically a table that has some data types in it, and then within that index you put some records, which are documents. I don't know why they called them that, and they couldn't just use normal terms, but yeah. Let's see. Okay. And the cool thing, I guess, a cool thing about the way that they store stuff is that the tables have a schema, which they call a mapping. And you can have multiple tables share the same mapping. So in one use case, they ingest logs and they do logging. And to make search really fast, you can kind of search across basically all things that share the same schema, or you could search just the ones in 2018, or just the ones in 2018 in January, or just the ones on a specific day. And that would increase your search significantly if you've kind of broken down your data in that way. And so that's, I think I have another slide about this somewhere, but that's kind of the biggest thing about Elasticsearch, is you really need to know what your use case is before you start slamming your data in there. Unlike a normal database where you can get around and start adding foreign keys and all kinds of stuff later to tie stuff together if you didn't kind of construct the database correctly. Here, you kind of really need to know what you want to search on, and if you need to make it fast, or if you need to update the records. So at work, we don't update, so we don't really care kind of how we constructed our cluster. We just want as fast search as possible. So we've broken down our data in such a way that it's very fast to search in a case like this for these kind of the way they've broken it down here. And so what they do, the reason why it works fast is they have what's called an index, and an index is broken into shards. And here they have 3 nodes, and they have this master node, and that doesn't really matter anymore. And what they're going to do is, what you really want is to have your data broken down in such a way that you send a query, and that there's some data on one node, some data on another node, and some data on a third node. And each of those nodes is running in parallel, and they're going to return their results. And so they do this thing where they talk about splitting your data in a way that makes the searches fast, and this is one of them. So really you don't want, I don't know how to put this, memory is a big problem in Elasticsearch because of a very memory-heavy application. So you kind of don't want, when you construct these shards in your index, you don't want them to be bigger than the memory on the box, because then the box has to do a lot of swapping, and it has to have multiple shard files kind of open. And I can show that a little later. I thought I'd just mention it.
Would all these nodes be on separate servers or the same server?
No, they're separate servers. Yeah. Yeah. So on this one, you can see they have this I think yellow. I don't know. I can't read it here. Yellow is this primary shard. So they have X, Y, and Z is one index that they've sharded 3 times, and you kind of do it across the amount of nodes you have. And then they have these replicas that if one of the nodes dies, they still have some of the data. And you can recover, recovering the cluster is pretty easy. I think it's kind of if anybody's used Cassandra, you can kind of add an additional node, and you can just update. You just restart all the boxes, and they'll find it, and they'll start splitting data across, right? And so there's a lot of Java tuning, but as far as this sharding goes, really all you really care about for an index is the amount of shards. You don't really, everything else kind of happens under the hood. It moves the data around. You can tell it where to put data and some other things, but they recommend against it. And so this is what it makes it really fast. As you can scale your cluster, horizontally, and the searches will get faster and faster and faster as you sub-split the data more. Just throwing more memory at a problem doesn't really necessarily make it faster, because if you only have one node, it still has to churn through all that data.
Now, you're managing the sharding, or is the software managed?
You tell the index. I'll show you when I show you an index that by default it's like set up to have a certain amount of shards, and they have some recommendations in there. There's like a YAML file that's like, how many nodes do you have? Okay, make that the shards. So you tell the index how many shards it should have. Yeah. And so one downside of this, again, it's a search engine, not a database, is that you're never guaranteed. In a normal database, you would do a search and you could be guaranteed to get the exact document count, right? You could be like, there's 1,000 documents or 1,000,000 documents, and I'm going to ask it how many there are, and I'm going to get 1,000,000 back. And Elasticsearch is like, there's some. It depends like what nodes returned what quickly, and so there's like a guarantee that you'll get if you do a rank search that you'll get the stuff technically in the same order every time, I think, because of the way that's ranked. But if you do like an unranked search or some other stuff, it's like, well, if you run this query again, you might not get the same results. Or if you're trying to walk across the entire database, which is really slow, like it may leave records off, or it won't tell you the real number, right? You'll have 1,000,000 and tell you got 9,998. It's pretty close, but as like you get closer to the amount of memory on the machine, it can't hold all of the stuff. And so that's, some people run a problem if that's their expectation. And the other thing that we've run into at work is, again, it's not a database, is once you put your data in Elasticsearch, it's very hard to get it out, or impossible. Unlike a normal database where you may have a data file you can like export to CSV, they don't really, unless they changed it, they don't really have anything like that because of the way the indices are stored. So it's kind of like you should really keep your data, your actual true data, somewhere else, and load it in here just for searching, but have like another copy of it, because if someone wants 100,000 records out of the database, it's not non-trivial to try to rebuild that. So as I mentioned before, this is like, it's like a little picture someone made that the searches happen in parallel. So he does a search, and it sends part of the search to node 1, which has part of the one shard from the index, and node 2 has another shard from the index. And searches happen in parallel, and they're combined and sent back to the client. And there's some tuning required, like I mentioned, to get the max performance in the files. And the structure of the index kind of should be based upon the type of data you have. And so I talk about that when we go look at some searches. And so so there was a Five Guys. I mentioned Five Guys before, and their other big use cases. They call this the elk stack now, if you've ever heard of elk stack. So there's some products out there like Splunk being one of them. That was really big a couple years ago. And the more data that you ingested into Splunk as a DevOps person, you had to pay more money to Splunk. And there's like Datadog, which they do, what do they do? Like log aggregation on like AWS, right? But they cost money to use. And so elk stack, they're using Elasticsearch in the background. They have this product called, these are free, called Logstash and Beats. And they call Beat is like it's a heartbeat. And it is like pulling logs from your cluster, and it's dropping them into Logstash. And then they have this, I'll show this front end later, that you use Kibana, and you can go look at your logs. And kind of before how I had the indices like broken down for searching, usually they do like all your logs for a single day, because really you only care about like the most recent. Usually you care about the most recent, and you're going to roll off your data. But this is like their big, I think this is a much bigger product than the search product now, because a lot of DevOps shops, because it doesn't cost, it's free. And like I mentioned before, they said Lyft is doing 3 million events per minute from their their servers all over the world, and a whole bunch of other people use this too. And so I think that's like the big use case now. And I don't know that much about this because I don't use I don't use Logstash at work, but I know there's a lot of people that use it.
As far as the logs go, is it like a focus on like activity or performance or?
I think it's doing your server logs, right? So, and then it's going to be quickly. You have a million instances, right? Like if you're Lyft, like who knows how many Docker containers or whatever boxes they have, and then you had an error, and you want to know where it occurred. Well, if you have all the logs and you can search quickly, you can like dive into that data like really fast and find where the errors were. And so that's the use case that they're kind of coming at you with. And then maybe you have those logs stored off somewhere else or whatever. I don't know what you're going to do. And I think they have another one now. They have like a ML, they have a machine learning offering that they're like, oh, well, if you take in all your logs and your logs are looking at network traffic, well, then we can run this like ML job across it, and we can see that like this is non-standard traffic. Like maybe you're getting hacked or something like that, right? Like the more traffic you have, you can start kind of doing some analysis, and that's another thing that they kind of push now. But again, I've seen it. I've never really used it myself because we haven't had a use case for it at work. Yeah, and so this is like the not free stuff. This is, and so they have on here, they have security, alerting, monitoring. They have now an SQL offering, which I heard is going free, that you can somehow query against it with some SQL syntax. And I think that's for people doing like big data stuff with Spark maybe, that they wanted to use that. They have this ML, and they have some kind of graph database now. And monitoring kind of went free. You can monitor like you can have a certain amount of logging servers now. Like you can have all your stuff send logs, but only to one box for free. And so if you have too many boxes, it gets like overrun. But they are in 7. They made some stuff free, but I don't think they've updated the website. And I've heard, yeah. So I was going to say that the downsides of Elasticsearch. I mentioned this one error. It swallows a lot of error messages when you're updating documents and searching stuff, which is not very nice. Again, it's written in Java, so it uses a lot of memory. There's a fair amount of planning involved, especially at the beginning. Having used it for a while, we first started with 2x, and I had another cluster was on 5x, and somebody else ingested the data originally, and we had to do kind of a lot of tweaking and re-ingestation of data after we kind of figured out what it was that we wanted to do with Elasticsearch. And if I had known what I wanted to do in the very beginning, it would have saved a lot of work. And it kind of has limited use cases. So it depends. I think most enterprises probably don't need it, but if you have a product that search is a big piece of it, then it's probably worth checking out. Like I said, like one of our clusters at work, I mean, it's like 100 million things that we're searching across, right? Which is a lot. That's not a typical website. And it's changing very frequently. And so I was on 5. We upgraded to 6 a month ago. 7 came out. They changed a bunch of stuff again. And they're pretty good now about not messing with the indices too much, but they're like changing some of the APIs. And so that might affect how your searching is done depending on what version you've written it or wrote it in. The one nice thing is that because it's in JSON, stored in JSON, upgrading the cluster is usually pretty easy. Like you have to shut everything down, and then sometimes there's a re-index step that has to be involved if the version's too old, but the cluster will handle that for you. And I think in our case, it was like 2 hours of downtime for it had to churn through all the data and do some changes. So from that aspect, it's a much easier upgrade than potentially like a big SQL database potentially.
You said scaling out horizontally is pretty easy.
That's their whole thing. Yeah, you just add more nodes. Yeah. Okay. So I'm going to show like a demo. And if people have questions, I might have to look at Stack Overflow. Well, not Stack Overflow, but their documentation a little bit. Let me find my other browser window. Okay. So I mentioned to Brian. If you go to this like cloud.elastic.io, which I hadn't used before until last night, they give you a 14-day free trial with no credit card. And this is a pretty, I don't know how big this cluster is. So they got was it they got 3 instances in GCP. It might be 5 instances, and it'll let you run for 14 days, full up 100% of the time. And they provide you with there's test data, which is what I'm going to use. They have a bunch of test data that you can mess around with. So this is a good way if you want to mess with Elasticsearch, kind of poke around at it, that you don't have to set up a cluster on your own machine. Yeah. And so I will show. This is Kibana, which is their front end, which I don't really use a lot of. I've never used half of these tools in here. I think they have a lot of stuff in here now. They have some visualization dashboards, which I guess you can do that now. They have this Canvas thing, which is brand new. They have maps. They have this machine learning stuff. So there's a lot of stuff that they added in here, so maybe the use cases have changed a little bit. But the one thing we're going to look at is we're going to look at this thing called DevTools. And like I said before, everything is it's a JSON request to their server to REST endpoints, so we can see their query syntax is a little bit weird, but we can get like we can get the indices on the cluster. And so I don't know if you could see. Over here, they have some of these sample data, right? This Kibana sample data, e-commerce, Kibana. They have logs and they have flights, and so we can go look at some of the sample data. And this will kind of show you what an index looks like. So this is an index, right? This Kibana sample data flights, and they have this thing called like aliases, and it has no aliases that you could give multiple indices the same alias, and you can search at an alias instead of an index name. And then they have this mapping, which I talked about before, which is basically the column schema for this thing. And so you can see that it has these properties is basically the columns, and then they have these types. And so the big ones is this keyword, which is this is a non-ranked enum, right? There's no ranking here. It's like carrier or destination. Those are going to be city names, so something that doesn't change and has a finite number. And then they have some geo points, and then let's see, do they have text in here? So this one doesn't actually have any text in it. Let me see what the other one has. I thought one of these did. Yeah, okay, then they have like customer last name is text. So that's an actual text field that you can search across and is going to give us rankings back for this data e-commerce index. And then I think if I scroll down in this settings, they tell you the number of shards. So this only has 1 shard, so maybe it doesn't have that much data. They have 1 replica. And this is all stuff that you can set when you create the index. So let me pull up. I had some stuff around here. No. So you can like make a new index pretty easily. You can put an index. This one I have an analyzer on it just to show you that how the analyzers work. You can actually see what the analyzer does. Let's see if this actually ran. Okay, yeah, cool. And like I said, sometimes this thing will like swallow. It'll tell you it's acknowledged that it worked, and really it's just swallowed the error. This one did create correctly, but I was having some problems with one last night. And then you can see, let's see, that this one it's going to run this text Sammy Davis Jr. against this standard analyzer, and it shows you like the tokens that it's broken into. So if you have an analyzer and you're messing around, you can actually kind of see what's happening. This is what's happening under the hood in that index that I just made. And then here's like another one. Here's a quick brown fox. So you see in this one, they keep the now. They didn't used to keep those stop words, and then it tells you kind of what tokens. Now it keeps the S for some reason. They didn't used to do that, and it just shows you the tokens that it's broken into. And so they have like stuff for different languages. I think the standard tokenizers just do like English, but they have tokenizers that will break like Japanese, like hiragana, katakana, and Chinese into tokens, because those characters, like a single character is a word sometimes. And so you can, if you have a use case where, you know, people are searching manga and they want to find a certain Japanese phrase in a manga, you could like index that in Elasticsearch. And it'll do like emojis. I think it's UTF-8 or UTF-16. I don't remember if this tokenizer does it. There was one tokenizer I think we got to add at work, like if you wanted to like use emojis or something, some like kind of weird character sets. And so the other thing I was going to show, let's see. So what they have is they have this other thing, and they call it a template. And so what you're going to do in Elasticsearch is take logging as an example. Is that every day you have to make a new index for the logs you're going to ingest for that day, which is one of their use cases in Beats. And so you can make these templates, and the template has this index pattern. And so what this basically says is that if I make anything that matches these index patterns, this template will apply to that index. So now I don't have to like assign it will just get these settings, right? So you can just have a cron or something that's just pushing stuff, and it just says, oh, make a new one called test, and then it'll match this index, and it'll get these settings where it has a host name is the only keyword in there, and it has a created at date. And then if I put a new, let's see if this works. Indices. There's tests. And I should have it got all the properties from it. So it has the same created at date, and it has the same host name, and it has the same settings that were, I think some of these are defaults, but they were set in that template. So that's like one of the things that you can do is you can make these templates, and as you create more indices in your cluster, it kind of handles everything for you. And I guess I'll show, let me do some, I'll show, so we'll go look at, so I'll just show you kind of how some of these searches look. So this is the flight data. There's no text in here, but this is like a simple post. I can show you that. Let's see. And the endpoint they use for everything is this _search. And this one is just going to pull, it has these terms that it's matching. It's going to say if the day of week is 4 or 5, right? And that's one of the results. Let's see how long this takes. And you can do a bunch of really complicated queries. Let's see. I don't know. It might have died. I don't know. Does anybody have any questions, or is there anything you want to try to show one of like the ranked ones to show you what it brings back with?
So what are you posting right now?
I'm trying to search. I'm using what's called this. Okay, so I'll explain this because I didn't really explain this earlier. So they have this query. This is their DSA. This is their domain-specific language, and it always starts with this query block. All right, and the query is always considered a ranked search, but they have this what's called a Boolean, and this is the stuff that's kind of hard to suss out. You got to read the documentation a lot to kind of figure out. They don't really have many good examples. It was like a bunch of Stack Overflow posts to figure out how you're supposed to pass stuff. And they have what's called this Boolean, and the Boolean says it either has to match this thing, right? It has to match, not partially match. It has to match true or false. And what we're using is this thing called a filter, and so it's inside a Boolean. It always has to, I think, kind of be inside a Boolean. And we say, does it have in its terms, is its day a week 4 or 3? But a filter, it does not do ranking. There's no ranking happening. So it will come back fast. This one, I don't know why this just died. Okay, here it comes. It should come back much quicker than if I was doing a I think I can search across the keywords. I'll try to show that. Than if I were to do an actual query that is trying to do ranking and is looking at the indices some more. So you see this is like the standard data that comes back as this hits block. And they'll tell you, I don't know, can everybody see this? Sorry, I don't know if that's big enough for everybody. Yeah. So they tell you the amount of shards that it searched and like they'll tell you which shards were like part of the search. So this one, there's only one shard on the index because it's a small cluster. And then they have this max score 0 because there's no scoring happening, there's no text fields. And they'll tell you how many records it searched. So they say it searched 3,915 records. And then they have this hits, which has some data. And this is like in this source block. That's the actual results that came back. Or actually for each hit, the source is like the actual information. The stuff at the top is just some like index information. So they show you like all the flights. Like here's another flight that matched, right? And then its day of week down here is 3, right? And so you could match a combination of these, and yeah. And it's supposed to come back. I don't know why. Usually it tells you the time. See, again, this is another thing they might have changed. Usually it says like, oh, took 10 milliseconds or took 6. So I don't know if that's 6 seconds or 6 milliseconds. And this is one of those things where like, I don't know if other clusters work like this. If you search across the same data all the time and it has a bunch of indices, it can't load all indices in memory. And so if you have users, if logging is your use case and all your DevOps people are searching against today's logs, those searches will get faster and faster because it will keep those indices that it continually searches across in memory, and it versus some other ones where like when the cluster first loads for the day or whatever happens to be, it just kind of has random whatever in memory, and as you search it starts shuffling stuff around, and the more you do searches it like weights those indexes, what it has in memory higher than what's not in memory. And so sometimes you'll have a query, it'll take 30 seconds and then you'll search again, and or you search a couple minutes later and it'll be like 5 milliseconds because it kind of already has that data kind of pre-popped. And so let me see if I can do this without a filter and see if it. No, that doesn't like that. Okay.
So if you want to actually insert data into Elasticsearch.
Oh, I'll show you. And I had a problem with this last night swallowing stuff.
I mean, the post is what's throwing me off there.
So they do a post and then they put, what was my thing? It was like put, and then it's the index name test1 _ doc, and then the ID. The ID is this 1. Let me see if I can make this a little bit bigger. So that's basically like, oh, put a new record in test indice 1, and they have this doc. It's like this doc thing, and then give it the ID number 1. And then you could be like, I think it had like a host name, and so then it would be like, whatever, host name equals Bob, and then it gave me like a root. Cannot merge. Maybe there's already a record with that ID. I think you can post too, and it's supposed to update it. Yeah, I don't know what that. I don't know what's in here. Yeah, it's kind of, some of them are really weird, and they have these weird underscore endpoints, which if you don't really know, you got to look at the documentation. And they've been changing a lot of that stuff. They had a lot of stuff about the cluster was under this underscore cat. It was an underscore cat endpoint, and they've kind of started to take stuff off of that and give it actual routes. Like, oh, if you want to know about the cluster, it's like /cluster now, instead of underscore cat /health/ some of their weird endpoint. Let's see. Search. So they have this other query called is match all. And we can see what's in there. There's nothing in there. I don't know why it doesn't let me put that record in. Because it said there's no hits. It's supposed to match all the. Oh.
Is it because you're using post and not get?
No, that's their verb. That one actually is. I had it written down. I have one. I thought I had a post in here. I thought I. Oh, well, that's the search. Yeah, I was looking for one. I had one that was like putting a record in, but maybe I didn't save it. No. Yeah, and the other thing that's hard is like sometimes it'll end up swallowing the records. Like some of them you have to put like all the fields in on some of them, and like they're required or they're not required. And I don't remember how to see that data off the top of my head. So if you don't put the fields, if you don't put all of the fields in for the record, like if I try to put a new flight in the flight search, and it'll tell me, oh yeah, it's exceeded. It'll come back. Habana will say that. It'll say it's exceeded, but really under the hood, it didn't do anything. And that's the only weird. I don't remember if it's the same error that I don't know if this happens if you use their libraries, because I can't remember because I only use the Node.js one at work. Like if it's better about giving you an error back. And part of that reason is they kind of have this thing under the hood that like they kind of do what garbage collectors do. They have a mark and sweep. So when you put a new record, it's not actually put in yet. It gets like put off to the side, and then it gets put in the database, and then it gets like kind of merged into the index. And when you delete, it like marks stuff as deleted, but the records are still hanging around for a while. And I think that's part of the reason why you don't get these like good error clauses, because it hasn't actually errored out yet. It's like, oh yeah, it's deleted, but not really.
So do I have this right, that the way it works, you're building a web application, and your users are on there, and the stuff that they're doing feeds data to the database. And then Elasticsearch sits off to the side, and when they click into the search box, it sends a post request to Elasticsearch,
Yep.
which is the database, which goes back. But it's managing its own, like, it's got its own conception of what the state of the database is.
Well, you have your own data. Elasticsearch has its own data. It doesn't look at your database. It's like you have a record, like you have a really complex record, right? Like, I don't know. I'm trying to think like it's like a customer, and they have like a bunch of orders and a bunch of other stuff attached, right? But maybe Elasticsearch, all it does is store like the order information, and each order record in Elasticsearch points back to a customer. So for like the people that are maybe like the support and they need to look up orders really quickly, they search in Elasticsearch, and then Elasticsearch links to the actual database. And so then they can go see all the user information or whatever, customer information, along with their address and their credit cards and everything else that goes along with like a normal user record in a e-commerce database.
So it's only storing key pieces of information from the database, not, obviously that's part of
That's the UKit. You could put a lot. You could put as much in here as you want, but they kind of expect you to have this flat file format that you really are not updating very frequently. You're maybe putting records in and deleting records, but you're not really ever like updating stuff all the time. Like, it's not really their use case that you're like going in and like, okay, I need to go I need to update every record in Elasticsearch, and now I need to change everybody's address. You're not really going to do that. I think it's like somebody changed their address, you delete the stuff out of Elasticsearch and you put a new record in. Because of the way the indexes work, and when it has to re-index the data, it's not particularly fast. It takes a while to churn through its stuff. So I think that's kind of the expectation.
The strategy that we use, or at least the perspective that we look at, is that our database is the source of truth. That's what our users are like putting content into and stuff like that. And then the index is just a glimpse of that is optimized for searching. So if you're thinking of something like a product catalog where you have like the name of the product, the SKU, the description, stuff like that, and then like a full text description and images and all that kind of stuff. All of that resides in your database, but within the index that's made for searching, you're probably only going to store the SKU, the title, and like some metadata, maybe the description, but like a lot of the extra stuff you're gonna leave out in the index. And then whenever a user goes to the website and they're searching through your gigantic product catalog, they are just querying the Elasticsearch index for the things that are searchable. And then once Elasticsearch finds that information and returns it to the browser, it is returning a list with that payload of information. But then whenever you click on something, like whenever you click on a particular product, it is pulling, like the website is now pulling the information from your database that has everything else coming with it based on the ID that was stored in Elasticsearch. So it's like the user goes to it's like your database goes to the index, user searches the index, and it brings it back to the website, and then you go and get the information.
So then you only need the amount of information that you would put on like a results card.
Yeah.
And the index should be like you should be able to blow away. I mean, like you wouldn't want to, but you should be able to blow away the entire index and recreate it from your database because you were just inserting stuff into the index.
Yeah.
Like on the management side, like whenever we have a user who's administrating the website and they're updating like a product post or like an article post or something, when they click save, their data is being saved in the website, and then there's a hook that says, okay, and take this bit of the data and then insert it into the index. So it's just like an ancillary step.
Yeah, I mean, I think it's the same way, like depending on what your use case is, usually it's like, if you look at Google, and especially Elasticsearch kind of works like this, right? You care about that first page or search results, it has like 30 results on it, and as it gets deeper into that, as you click through the pages, they get like less and less, they're not the search you maybe wanted, right? It's very unlikely you're gonna find that Stack Overflow answer that was gonna help you out on page 5. And so Elasticsearch kind of has this thing too. They'll return to you. I forget what the setting is, but they'll return up to 10,000 records in a search. Kibana just does 10 by default, but I can send like a size parameter and I could get 500. And so they have this 10,000 thing, and then they have this thing called a scroll that is basically asking for a page. You're basically asking for paging because they don't really have paging. And the scroll, as you go down the scroll, it takes longer and longer and longer. So maybe the first, you get the first 50,000 records, they only take 10 seconds a piece, and then stuff starts taking minutes because the deeper you get into the index, the data's like, they're going deeper down. And so I think their expectation is you're not really, like they're like, yeah, it's there, but, we don't really recommend, who wants more than 10,000 items back at a time? Yeah.
So I have a question. What is how are records represented in Elasticsearch?
It's,
Is it just a strictly JSON record?
I mean, it's this,
Are they stored as JSON records?
it's stored in that, it's stored in that reverse index, right? So how Elasticsearch represents that index, I don't know, but the record is a JSON. It's whatever is in this JSON hit, right? So in this one, it's like it looks exactly like JSON. It's like, oh, there's the message, and here's the string.
Log message and on your, I guess in your indexes, how do you define the actual properties that get stored and searched up?
So that's this. You can put a mapping when you make the index, but I'll show you what. Let me look at this index really quick. Kibana sample data flights. So they have this sample data flights, and they have this properties block, and then each one of these average ticket price, that's a field. And then they're saying this type is float. And so when they created the index, you could actually like copy this whole, you could copy this whole thing, and then I could be like, I could put like test flights, I think. Oh, I'm like 1, 2. Let's see, I think I'm 1 too deep. And when it's going to churn, like that's literally, I just made a new index that was an exact copy, so I could go in there and change all that stuff.
All right, and then when you ingest it, does your data have to have values for each field that you can find in your index?
So I don't see it in here. It's supposed to tell you this is stuff that they've changed. And so when we are in 2, and we have a cluster that's on 2, that's one project, and we have a cluster that's on 5, 6, and they have like a required field. And if it's required, the record won't go in unless you provide it. In our case, you have to provide it like a sane default. And there's some ways to kind of work around that. You can say, oh, I want this, if it's blank, to always be a blank string. But it looks like they've gotten rid of that. And they have this other thing that it'll like auto ingest records for you. So if you don't know what your schema is, if you never messed around with Elasticsearch before and you don't know what your schema is, you can just like throw, they have this way, I forget what it's called, that you can just like make an index and you can throw records at it and it'll be like, oh, I'll just come up with a schema. I'll come up with a template for you, a mappings for you. And it may not be the correct one for your use case. It thinks a lot of stuff are full text when they maybe aren't, but it's like a good way, like if you don't really know what you want to do, you could ingest a bunch of stuff and see what sticks kind of thing. Yeah.
What's the primary means of ingesting Elasticsearch data?
JSON requests.
Okay, so like you've got, a couple 100,000 records,
I think so. We use let's see. So I got their website up, and they don't have the best color on here. And then it's like document API, and they have like a bulk. I think you can do like bulk. You can somehow put bulk items in. And so we at work we use Spark, and there's a Spark connector that talks to Elasticsearch that does some weird SQL stuff that Spark does, and it like ingests the stuff for us. And there's no JSON in that because they're doing something under the hood. So I've never actually, I don't think I've ever used any of these like bulk requests before where you can just post a whole bunch of stuff at one time. And we went back to them before too, and we asked if they do JSON B, which if anybody used that, it's like a binary wrap or binary JSON. Because sometimes you'll get, if you try to get 10,000 records back and your stuff is real big, I've gotten like requests, I'm like, this is a 20 meg request. And like, you guys got JSON B? Like, nope. Like, maybe don't do that. So that's like another downside maybe of like, and I don't know, here they're just showing you, like they're doing this post bulk. They have a bunch of tools, right? Like if you're using Node.js, you can get the Node.js connector, and if you get, whatever you're using Java, you can get the Java connector. And some of those are open in sockets. I think they're doing a socket. They're opening a socket, but you don't see that, right? Like you can't. You probably could figure out what it is. So they might be pushing the data in there a little bit different. I mean, you can see it go across the wire, but you can see a socket open on some of the libraries depending on what they're doing. Yeah.
How heavy is the maintenance on this? Like to set it up and to maintain it for a project or projects? Like, do you need like a dev, or do you need a team of devs, or?
I think so. Let me see if I can look at these indices really quick. So this is kind of where it gets into that. Let's see what they got in here. So it depends how much data you have. So they tell you here, like these indexes are only like 22 megs, right? So I kind of, if you have your data kind of all taken care of, like they have this thing where a lot of stuff used to be manual. You have to run these crons at night, and when you have like your shards, and you don't want your shards to be too big, right? Because they don't want to be bigger than like the amount of memory on the machine. You don't want a 128 gig shard, and you got 32 gigs of memory, and so you would like break up the index, and you could like re-index. Well, you make the index like smaller than how much memory you have, right? So you have like a data for a day, and really it's 200 gigs of data, but you can like subdivide it. You can make like 5 indices out of it. And so a lot of that was manual before. And in Steven, they added stuff that when you make the indices, you can kind of, some of these, you can have it do it automatically. You can say like, oh, I never want the index to get over 10 gigs, and it'll do what's called like rolling. It'll roll it. And so if your index is called, whatever, Chris's cool stuff, right? It'll roll it, and it'll automatically make one like Chris's cool stuff 1. And then when that one fills up and it hits the 10 gig limit, it'll automatically make another one. And when you search it, you're really just searching. You're going to search like Chris's cool stuff star, or you're going to give them all an alias that's just like search, and that's what you're going to use. And you don't care that it's got 50 indices or whatever it happens to be.
So do you need to know when it's rolled?
I don't think you care. It figures out when it's not getting. It's supposed to figure out when it's not getting hit. Supposedly.
Just do search for Chris's cool stuff, no star, it'll treat it as though there's a star?
No, so you can give, that one is like it's going to search the exact index, but you can give the index, you can give, if the indices all share a template, you can give them all an alias. And then the alias, you can just search that alias. So you can just call the alias like search stuff, right? And then you can use that term. And so like at work, I think we have an alias that's just like records, and we just search on records, and there's like, 200 indices that all have that alias. And then if we want to subdivide the search further, we can start doing that star stuff like, oh, I only want stuff in 2017, or I only want, whatever it happens to be, for performance, depending on who's searching what and what you care about. And we care about search. The project I'm on, like search speed is like a big deal to us, because we're trying to get a lot of records really fast, and we're not doing full text. We want counts of stuff to like display metrics and all this kind of stuff. So we want a lot of data really quick. But maybe for other people, maybe that's not their case. So, yeah.
So does all the administration, so all this is in there in Elasticsearch's language as far as querying and inserting and stuff, and then all the the maintenance that you're having to do, like managing the shards and all that kind of stuff. I'm assuming that's all Java.
It's really like at work. I'm trying to remember what we got our package for. I mean, it's literally a Yum package, and we just installed Elasticsearch, and it's got like one YAML. There's like 2 YAML files, and you set a couple settings, and you just make sure that same YAML file has the same settings across the cluster.
Oh, so you're not diving into Java at all?
No. I'm just saying it comes with the memory issues that if you're used to working on enterprise Java projects that you kind of have to be aware of. Like on this one, we had to set a bunch of stuff. They really care about heap sizing, and how many documents are open. And you got to make some changes in Linux to make the search faster, because they don't want the swap. They don't want swaps happening, and you kind of have to size your memory. They have a bunch of they have a whole series of documents on like how you should size everything and how big your heap space should be, and you just kind of go set some Linux parameters, right, and some Etsy files. But other than that, you don't really have to. We don't babysit it, I guess, if that's.
We were looking to leverage Elasticsearch on a project and several projects since then, and we ended up going with Algolia, which is a service, I believe, built on top of Elasticsearch, but you're giving them the indexes and they're managing it.
Oh, okay.
And we were trying to weigh whether or not we should try and handle Elasticsearch in-house or handle it on the service. We ended up going with the service because, but it was because we didn't have any Java developers. We didn't have anyone that would be dedicated to watching it. But if it's not as critical, because like the indexes aren't like relative to the indexes that you could have on this are not that big. So
Yeah, I mean, you can run some of it in Docker and containers. Are really like, I think coming through a lot of versions kind of sucked, right? Because they like removed types and you had to change all that. There was a bunch of stuff that happened, and like now I feel like if you watch like a couple training videos, you can kind of get a good feel. And I think the biggest problem that we had is when we originally ingested our data, it got auto ingested. We didn't know that much about Elasticsearch. Someone was like, yeah, let's use it. And whoever ingested the data, we auto ingested it as text, and we really wanted keywords, and so the searches were much slower than what they should have been because a lot of it was enums like state names or whatever kind of stuff like that. And so once we fixed that, and the index was really deep, and so it's kind of going to be like a NoSQL. I think like if you've done NoSQL stuff, that you really shouldn't be making fields within fields. You kind of just have a flat structure, and we had a problem with it. There was stuff that was kind of deep, and it's a little bit harder to search on some of that stuff. But now that we've I've had to rip that Band-Aid off and fix it, I'm like, oh yeah, okay, yeah, I kind of know what I'm doing now. It's not too hard. And you probably only have a couple queries that you want it. I think most projects only really have a couple queries, even though the website's like really kind of complicated. Like they have all these search queries now. This isn't the one I was looking at. Like they have all these aggregations and pipelines, and you can do all these counts. And they have a bunch of new search stuff you can do in these like complex searches, and you can run scripts as part of the search, which they have that you can do these combo fields. You can return first name and last name as a combo field, and then they tell you in the documentation not to use any of it because it slows everything down, because it's not what Elasticsearch was really meant for. So we don't use any of that crazy stuff, so it's not really that complicated. And I don't think most people, just from looking at Stack Overflow, I don't think. You might have like one search case where you need to use that one thing one time because someone wants that metric, but for the most part, you usually like, oh, I only want this or that really fast.
It sounds to me like in the usage of this is more for finding the n number of things rather than the one thing. So that it sounds to me like in use cases more like I need to know how many times this occurred rather than finding this one occurrence.
Ours at work is, yeah. But if you use the text search and they're ranked, the thing that matches closely is going to get returned first. So you're only going to return 10 results, and you were looking for the quick down brown lazy dog jumps over the whatever. And that's going to be the result that gets returned with like the ranking one. It'll see if I ran this other query. And it'll give you by default. Let me see how. It will return, it ranks them, and so the one that has the highest rank comes up as the first item in that hits array. And you can like boost stuff. They have this like other thing called like boosting. And so if there's a thing that you care about that maybe isn't going to match exactly, but it's important to you, like I don't even know what a use case for that would be. Like maybe you're searching, like stuff online and you care about hashtags. And so things that match a certain hashtag, even though the text of the whatever someone posted on Instagram doesn't match 100%, but the hashtag matches really closely, you can like give it like this boost parameter, and you can boost the score. You can push the score up if that was a use case for you. And I think a lot of people are using it for log searches. So they're searching for a specific error across a large number of servers, across all their logs, and that's what they want to see. That's what that log stash gives you. So you're hopefully going to get the needle in the haystack that you were looking for, as opposed to having to log into all the servers and grep a bunch of logs and have a crappy time. Yeah.
When you're doing a search, and you have these different fields, are you doing like for the data that you're searching for? Is it for each record searching through all the available columns? Like you're not saying I want this specific value and this specific column.
You can pass a block in here, which I think is a sort. I forget what it is. I have to look it up in the API. You can be like, I only care about these three. Okay, again, they changed everything. It's not just coming up in here. They had one where like, this one doesn't show it, and ours on our 6X cluster it does. Is you could pick certain fields that you wanted included in the document, but you didn't want to search across, that you don't care about any searching or any matching. So it would just include it in the returned result, but it does not, you can't search across it. So you just care, you want to search by social, but you don't care about searching across name, but you want the name in the record. And so you can put that, but it doesn't technically include it in the reverse index when it builds its tokenization. It's not going to tokenize any of those fields, and you can't search across them. But like you could still get that record. You could still get that record back.
So then would it only return the first and last name, or would it return?
No, it would return like first name, last name, social, but it only let you search on social.
So like if you had like an index full of users that had first name, last name, address, and phone number, and you didn't want the phone number to be searchable, but you did want first name, last name, and address, if you typed in like lantern, and like would it find, or lantern, like if you type in Johnson, would it find people with the last name Johnson, and then also streets with Johnson?
So this is I guess that's the one thing I don't know. I think you like, this is like where they get into this query term, and you can pass like multiple fields that you want to search, and I don't know what the block is. You like, I want to search, I have 3 text fields, and I want to find that text in any block. Usually like the stuff we do at work and most of the demo, we only have one full text field, and all the other full text fields are keywords, so we're really only searching one field. But I'm sure that's like, I've never done it, so I don't know what the JSON looks like. I think you can do like a Boolean, like I want this or this or this, like search across these 3 fields. And we don't really have that I don't have that as a use case. I'm sure you can do it. I'm sure it's supported. Yeah, and they do some kind of like address. They do stuff that'll parse addresses in one of the tokenizers, like for you automatically, or it tries to pick out addresses from text is one of their tokenizers that they have. Let's see if I can, like, I don't know where this is at. There's like a lot of stuff in here. Yeah, so they have like standard letter, lowercase, white space, email tokenizer. They have this ngram, and they have a bunch of other ones. And they have a bunch of plugins that you can load. So these are all the ones that come by default. And then they have a bunch of other stuff that if you're looking for something specific like IP addresses, they have like an IP address tokenizer. Some of it's written by them, but they just don't. It doesn't come in the default whatever the yum, whatever your repo is, right? Whatever you, when you install it, it's not installed by default because most people don't use it. I think Logstash, like that's the other thing. I think Logstash has all that because obviously that's what you care about. You're tokenizing logs. There's some things that are different than standard text, like the times. They're probably UTC time, or maybe they're only the millisecond string. So they're going to tokenize that differently than if you were looking at paragraph of text somebody wrote. Yeah. Any more? You guys got any more questions? No? Okay.
Well, hey, Sebastian, thank
Yeah.
you very much. Yeah, again, thanks guys for coming out. Feel free to hang out, just kind of shoot the shit or whatever. Please eat more food. Whatever you guys don't need, we have the cart out, dispose of, and I need more at your house. So, yeah, just hang out. In 2 weeks we'll be back here again, JSTL, talking about virtual reality. So, we're more welcome to come. So, thanks again, guys.
So what do you use, Chris? Oh.